Hello, my name is Camila Rivas, and today I'll be presenting my project for Math 2413 D71 Calculus 1. This project explores the U.S. economy using calculus concepts, particularly focusing on the unemployment rate and the GDP growth rate over a span of 25 years. In this project, we dive into how the U.S. economy shifts over time using two key indicators, unemployment rate and GDP growth rate. Unemployment tells us how many people are having trouble finding work, while GDP growth tells us how fast the economy is moving. Using graphs, derivatives, and critical points, we can see the ups and downs in the economy from 1995 onward. This graph models both the unemployment rate, U of t, and GDP growth rate, G of t, where time, t, starts at 0 for the year 1995. These functions help us visualize how each indicator changes over the years. Now, let's take a closer look at GDP growth. The critical numbers of G of t occur at t is equal to 2, 7, 12, and 22. These points represent major turning points in the GDP growth curve. Similarly, the unemployment rate has its own critical numbers. T is equal to 0, 6, 9, 16, and 19. Each of these values shows where the direction of unemployment rate changes significantly. I used the quotient rule to find the first derivative of U of t. After simplifying, I got the derivative, which I used to find critical points and see where unemployment rises or falls. For G of t, I used the chain rule. The first derivative of G of t helps identify where the economy is speeding up or slowing down. The first derivative test for U of t tells us where the unemployment rate is increasing or decreasing. It increases between 2001 to 2004 and 2011 to 2014, and it decreases between 1995 to 2001, 2004 to 2011, and 2014 to 2020. We also identify local maximums at 2004 and 2014 and minimums at 2001 and 2011. Looking at G of t, the GDP growth rate increases during 1995 to 1997, 2002 to 2007, and 2012 to 2017, while it decreases during 1997 to 2002, 2007 to 2012, and 2017 to 2020. We see local maximums in 2002 and 2012, and local minimums in 1997, 2007, and 2017. This is how I solved for the second derivative of G of t. Here we have the graph of the second derivative of GDP growth, or the second derivative of G of t. The inflection points where the curve changes concavity happen at t is equal to 4, 9, 14, 19, and 24. Inflection points in GDP growth are important because they show when the economy starts accelerating or decelerating. These points help economists predict future trends, whether the economy might be heading into a recession or a recovery. The U.S. experienced recessions during the periods when GDP growth was decreasing, 1997 to 2002, 2007 to 2012, and 2017 to 2020. These match real events like the dot-com crash, the 2008 financial crisis, and the COVID-19 slowdown. According to Okun's law, a drop in GDP growth usually leads to an increase in unemployment. This makes sense. Less production means fewer jobs, so companies either lay off workers or stop hiring. In general, the graphs support Okun's law. For example, between 2002 to 2007 and 2012 to 2017, GDP was growing and unemployment was falling. This shows that when the economy grows, companies tend to hire more. However, Okun's law isn't perfect. Between 2005 to 2007, GDP growth increased, but unemployment didn't fall much. That might be due to uncertainty or a mismatch in job skills. This shows that while the law is useful, it doesn't explain everything. There's a strong connection between GDP growth inflection points and unemployment. When the economy starts speeding up, businesses gain confidence and hire more. These inflection points can help predict changes in the job market. From this project, I believe that GDP growth tends to lead to lower unemployment. The data shows that when the economy improves, companies are more likely to hire. While the opposite might also be true, the graph suggests that economic growth comes first. Thank you for listening to my presentation and have a great rest of your day.